Welcome everyone. So in this video, we shall address the two forms of quadratic functions and how do you go back and forth between the two forms. The good news is there are only two forms, not four, as we did or saw with the linear functions. The bad news is it's not easy necessarily to move from one form to the other in comparison to the linear forms. It's not hard, but it's definitely a little harder, but I'm sure you can get it. So what I'm going to do is share with you the two forms and then show you how to go back and forth between the two. Now, which form is better? It all depends on the context, just like we did with linear functions. So you are very familiar with the standard form. It looks like this, right? We want to ensure that a is not 0, because if a is 0, then you just have a linear form function, mx plus b, right? So we want to make sure a is not 0. It's okay if b is 0. It's okay if c is 0. It's okay if both are 0, but definitely a should not be 0. Okay, so that's the only condition for this to remain a quadratic function. And the three parameters we needed to know in order to work with the function are a, b, c. If you knew a, b, c, you know everything you need to know, and you can answer any question that is given to you. Remember, a dealt with the concavity, c was the y-intercept, and a in conjunction with b together helped you find a vertex. The other form is called the vertex form, and the name says it all. It has the vertex embedded in the form, and it looks like this: a x minus h quantity squared plus k. Now sometimes you have k on the left hand side, so y minus k equals a parentheses x minus h quantity squared. The three parameters, just like in here, are not a, b, c, but it's a, h, k. Now what are these three numbers? Well, this a, here's the good news, this a is exactly that a. So if this is 2, I guarantee you're going to get a 2 here. If this is 1, you're going to get a 1. If this is negative 5, you're going to get negative 5. So that you get for free. Okay? Now hk is your vertex. Now remember, h is negative b over 2a, and k is f of negative b over 2a. Okay? So if you have a function, if you have a situation where the vertex is provided to you, directly or indirectly, clearly this is the form you want to use. Feel free to use either one. They're the same, I just moved the k here. The reason I did that is because some kids say, why do we have a minus here and a plus? The truth of the matter is there are two negatives, okay? Then why do we write it like this? Because we like to isolate y. So it doesn't matter how you write it, these are identical, okay? So now how do we, second piece of this presentation is, how do you go back and forth between the two forms, okay? The easiest one is if you have this form and you want to go in this form, into this form, you just have to distribute. Whatever is given to you, you square this quantity, you hit it with a, and you add k, and you're done, and you'll know what your a, b, and c are. So let me show it to you with an example. So look at the left-hand side, okay? So let's say I have a vertex form. Notice a is 1. Notice h is 1, not negative 1. See, minus h, but the vertex is h, okay, right? So the vertex here is 1, 3. That's your vertex. How do you go from the vertex form into the standard form, this standard form? All you had to do is to distribute. So we're going to distribute this. A minus b quantity squared is a squared minus 2ab plus b squared. If you're not sure, you multiply x minus 1 by itself, okay, and waste 10 minutes. You multiply this by itself, right? And you will get it. What you're not supposed to do, and I see this sometimes a lot, is for people to distribute the square like this, okay, or like that. Okay, that's wrong. Whenever you have a minus or a plus, you have no right to distribute and exponents, only when you have multiplication. Okay, so for example, if you have 2x quantity cubed, you have the right to say this, and that would be okay. When you have multiplication or division, that's okay. But when you have addition or subtraction, you don't want to make that mistake. Okay, so if you distribute this, you should get this, right? X minus 1 times itself, you should get this. Try it by yourself. Stop the video, try it by yourself, make sure you get it. And the 3 just carries. Now notice this x squared remains, minus 2x remains, and 1 plus 3 is 4. So clearly, this is in the standard form. A is 1, B is negative 2, and C is 4. Notice A is not 0, right? You cannot have 0 for A. So I have managed to write the vertex form into a standard form. I basically went from here to here simply by distributing. Very simple. This is very easy. To go back, it's a little hard, and there are 2 methods. Actually, there is more. But for now, I'm going to show you 2 ways to go from here to here. One of them is easy. This one, find a vertex. The other one is a little more difficult. Okay, so I'm going to show you both methods. How do you go from standard to vertex? So I'm going to pick a function in a standard form. A x squared plus b x plus c. I basically gave you this one. Okay, and let's see if we can get to here. Isn't that the question? Can I go from here to here? Okay, so how do we do it? Well, since you know that the vertex form has h, k, and a, if you know these 3 numbers, you could just plug them in, right? Well, we already know a. A is 1. So we know we're going to have 1. So I'm trying to get to here. I'm trying to get to here. That's my goal. I already know 1/3 of my numbers, A, H, K. I already know A. A is 1. This A here is exactly that A. So we know we're going to get 1. So that's easy. Okay? So how do we find HK? Well, you know how to find HK. You know how to find HK. We find a vertex, right? That's your H, that's your K. So minus B over 2A is minus negative 2. Remember, B is negative 2. So negative B is minus negative 2. This minus is that minus, and B is negative 2. Over 2 times 1, A is 1. So that gave me 1. So we know H is 1. I already know H. H is 1. Okay? Now, to find K, this is H, this is K. To find K, you just find f of 1, the image of 1. Well, it's 1 squared minus 2 times 1 plus 4. Okay? And what is that? Give me 1 second. What is that? So that's 1 squared, which is 1, minus 2, plus 4, which is 3. So now I know K is 3. And I already knew A is 1. And therefore, I know my 3 numbers. A, H, K. I can just plug them in. A, H, K. That's what I'm going to do. A, right? That's A. X minus H, and H is 1, plus K, which is 3. Done. And so I was able to go from here to here. Basically go backwards. Okay? Basically go from here to here by using find a vertex. That's what I did. The last thing I'm going to do is take this example again and try to get the vertex form without finding the vertex by what we call completing the square. Okay? And that is my second method. So this is the first method to go from standard to vertex, and here is another method. It's called completing the square. So let me pause here and show you something visual. If somebody gives you 8 little pieces, so we know 8 is not a perfect square. because it's missing this piece, right? If it's a 3 by 3, it's perfect. So how do you make it a perfect square? So it's called completing the square. This is not a square. That's a 3 by 2, and it's not a perfect square. So what I can do is add some quantity here, make it look like that. But if you add it, you better remove it. You can just add, okay? So what I'm going to do is I'm going to add this piece here. So that leaves me with this beautiful square. It's a 9, which is a 3 by 3, right? It's a 3 squared. That's a perfect square. And then I have to remove it. And here it is. I removed it. Basically, I called 8 9 minus 1. It's like, why can't you just leave it as 8? Because we want to complete the square. So we have no choice but to write it as 9 minus 1. So if you add something to make it 9, you better take it away. Okay, that's the main idea. The question is, well, with this example, it's so easy to add a little 1. So we knew 8 is 8 plus 1 minus 1. We knew 8 is 8 plus 1 minus 1. I made it 9, basically. But sometimes it's not easy to see what you have to add, right? And in that case, I'm just going to give you exactly what you need to add all the time, which is this quantity. Notice this is not b over 2a, like, you know, the h. It's not that, okay? It's close. There is no negative and there is no a. It's just b over 2a quantity squared. And I can show you in class why is it that we always need this piece. So here is how it works. You start with your standard form, and I want to write it in the vertex form. Here is what you do. You rewrite the quadratic piece and the linear piece, and you push 4 a little bit to the side, because we need to know what we're going to add. And I'm telling you to add b over 2 squared. So let's see. We know b is negative 2, right? We know b is negative 2. So we're going to add b over 2 squared. And that is negative 2 over 2 squared, which is 1. So what I really need is 1. So I added 1. And as I said here, if you add something, you have to remove it. By the way, you don't always add 1. I know we added 1, took away 1. And I know we're adding 1 here and taking away 1. Sometimes you have to add 5 and take away 5, okay? It just happens that in both situations you added 1. And therefore you have to take away 1. When you add 1, please don't cancel. Don't say 1 minus 1 is 0. That takes you back here. What you want to do is keep these guys together and keep these guys together. So this, I guarantee you, it's a perfect square. Whenever you add the piece that you are missing, like we added 1, we made it 9, which is a perfect square. You just got to figure out what is that perfect square. Clearly, you're going to need an x. You're going to have a square. And figure out what is that number that you need to write in here so that this is exactly this. And this left over, you just combine it. 4 minus 1 is 3. And once again, I got my vertex form, this one, where a is 1, h is 1, and k is 3. A is 1, h is 1. Remember, it's x minus h, so h is 1, and k is 3. And I'm done. So all you have to remember is move the 4 a little bit to the side because you need to insert something here. What do you have to insert? It's this quantity. And if you insert it, you better take it away. And please don't cancel 1 with negative 1 because that's going to take you back here. It's like you're spinning your wheels and not going anywhere. What you want to do is keep these 3 together in red and keep these 2 together in red. So that's just 3. And that is a perfect square. You got to figure out the perfect square. I mean, I'll share it with you the trick if you want. You do this. Obviously, you need x. And all you have to do is take the b and divide by 2. Just this. Just this. Now, b is negative 2 over 2 is negative 1. Done. Okay. I'm sure you can guess it. I'm sure you can just clearly you're going to need a negative number because positive number will give you positive, positive, positive. Okay. And you got to figure out, is it -1? Is it -2? What is it? It's not easy, hard to find. But if you're really in trouble, this is the piece, not this. This is the piece that goes inside. Okay. And this is over. Done. All right. Take care.